Always sounds so robotic. Literally. Sounds like a sat nav or something.
Yeah, it does. It does. You get used to it after a while. And cool. We got through the first few seconds, and everyone that is attending this every day is going to get sick of me saying this, but I always get scared when one of these starts, and I don't know if the attendees numbers are going to go up or not. And the problem is, I also have that light above me, so I look like an angel the entire time. So you may not be able to see me during the Sophie. Exactly, I've got a halo over me. For anyone that is joining now, we're just going to give it a minute or so just to allow people to get in. I know I've had a few people contact me via LinkedIn and via my email just to ask for the link for today. So we'll just give it a few seconds before we kick off. At the start of it, just in case people haven't been part of the other sessions, I'll do an introduction to myself. Sophie will give you an introduction to herself. We'll talk very briefly about hackajob, because it's not really the reason that any of us are here today, but I'll give you a bit of a insight into who hackajob are and what we do, and we'll go through the session. The session today is going through DevOps, so we'll be covering DevOps as a concept. How does it exist? Why does it exist? How does it work? We'll go through some recruiter insights at the end, and then I've already been sent 7 or 8 Q&A questions, so there should be a decent amount at the end. Please do get all your questions in. This session is scheduled to be an hour. If it runs short, it runs short. So yeah, if there's any particular questions you've got, send them across, and we'll go from there. We'll just give it 1 more minute and then we'll kick it off. And I have my trusty Coke Zero Cherry with me, so I'm going to be good for this session.
Essential. Essential for a successful TRT.
Exactly. It's got me through the first few days of this. After a while, because I've done this a few times now and done like whole weeks of it, by the end of it, you start losing your voice because you're talking a lot.
Yeah, absolutely. So, cherry every time? Do you change up the flavour or?
Well, my partner has brought them this week and she's gone for the Coke Zero. So I have to go cherry because I don't like Coke Zero normal Coke. So advertising for Coca-Cola on this call. So if anyone works at Coca-Cola, give me a shout. I'll give you some tips on what I do like and what I don't like about your drink. Give it 30 more seconds. Cool. I always wait till 3 minutes past. Cool. So we'll kick off, and then anyone that joins probably will join during the part where I'm doing the introduction. So for way of introduction, my name's Darren. I've been at hackajob for 5.5 years. I think I've said different amounts of time each time because it's been a long time I've been part of hackajob now. I head up our new markets team, so I look after our expansion into the United States, which we started in May. In terms of my background, so I've been in the recruitment industry for just over 10 years now, which makes me feel very old. Always within tech, specifically around cloud and data before I joined hackajob. So that's an introduction to me. Sophie, do you want to do an introduction to yourself?
Yeah, of course. So hi, everyone. My name's Sophie. I've been with hackajob now, I think just under 6 months, trying to remember. Working on the talent side of the organization, so looking after the candidates on the platform and kind of their journey with hackajob and everything along those lines. Prior to that, I've got a background in recruitment of around 3.5 years now, some of that in multiple industries, but around the last 2.5 years focused in tech. So yeah, that's a little bit about me.
Awesome. So for once, I won't be leading the first part of this, so we'll pass over to lovely Sophie in a minute, but just take you through the agenda. So we'll be starting with what is DevOps, talk about hiring DevOps engineers. That would be probably somewhat at the start and then somewhat at the end. Key concepts within DevOps, cloud computing, which we touched on a little bit yesterday, but we'll go into a little bit more depth today, service and deployment models, and then DevOps toolings. Over to you, Sophie.
Okay, cool. So yeah, I think before talking about DevOps and understanding kind of DevOps processes and tooling, it's quite interesting to look at the traditional process for software development prior to DevOps, basically. So this image here kind of shows your traditional process within the software development lifecycle before DevOps ever came around. So essentially it would work in the way where the software development team would write the code for the application. It'd then get passed over and chucked over to the QA team who'd test the code for bugs, make sure it's all working, and then again chucked over to the operations team who'd release and deploy the code. So this was quite a challenging process, quite time consuming, obviously, because it's going from team to team to team, really siloed because everyone's working on it in separate situations. And therefore it makes it quite slow and quite tedious to kind of work in that way, essentially. So then after that, kind of looking at what is DevOps, if we go on to the next one. So what is DevOps? I feel like a question that I know myself and probably many other tech recruiters out there have Googled at some point in life and tried to decipher what the definition means from Google. It's a combination of a lot of things, but of both kind of cultural practices within a team and the software tools that teams used, combining with the software development process and IT ops processes together to drive more automation across the software development lifecycle. So I think something important to remember about DevOps in general is that it's not a technology. It's not something that you can just complete, basically. It's a combination of a lot of different things, including kind of culture, software tools, all focusing on improving the process of writing code, automating as much as possible throughout that process, and getting it to customers as quickly as possible, basically.
Yeah, awesome. And I think that the thing I'd add on top of that is DevOps is a evolving area. So if you look at what is happening in the marketplace now, you're getting stuff like DevSecOps, you're getting FinOps. So there's lots of different concepts that are coming out, and we'll get through to it a little bit later during my section. I think one of the things that's always important, I think, within DevOps is not paying too much credence to what someone's job title is. So the best DevOps people I've ever seen actually come out as third line support. So it's always important to focus on what is someone using and what is someone doing in their day-to-day, not on their job title. It's not as simple as seeing a Java engineer and feeling like, okay, this person's going to be an engineer that codes in Java, because it's just not that simple in DevOps. Definitely.
So yeah, this is just a little diagram to take a look at, basically. It really, I think, shows what we were kind of talking about before, in the fact that DevOps is an ongoing process. It never stops, and it's integrated. The best DevOps, I guess, is integrated into absolutely every part of the software development lifecycle. And that is the true representation of DevOps basically being integrated. And it kind of shows that you can start from like your planning, your coding, building, testing, releasing, deploying, going through, and then back into your monitoring and planning again. And it really shows that it is ongoing. We'll talk a little bit more in detail about kind of all of these different elements and how DevOps integrates into them. But yeah, this is just a bit of a nice image to kind of show how it all flows together, but not sure if there's anything you wanted to add to that, Daz.
No, I think we go through most of these concepts as the section goes on. We go through containerization, etc. I think there's a lot of scary words when it comes to DevOps. Like, people look at a lot of stuff and feel, oh my God, what does that even mean? But I think DevOps, probably more than any other area of tech, if you actually look at the words, they'll give you a bit of an indication about what it's doing. So infrastructure as code, think about it. So it's infrastructure, but within code. It's as simple as that. Containerization we'll go through a little bit later and what it means, but it's essentially putting the code into a container, and it's isolating things from the rest of the code. So when you're thinking about DevOps, a lot of time read the words and it'll give you a bit of an idea about what that means.
Amazing. Okay, cool. So origins of DevOps, a little bit of history for everyone. So this slide obviously starts a little bit more about Agile, but it's quite interesting to think about what there was even before Agile culture as well. So prior to Agile, my mouth isn't working, businesses would use a waterfall development methodology normally. So that's starting a team working on your project scope, a team then working on project requirements, and then down to the developers, down to QAs, and then down to ops, going down step by step like a waterfall, kind of similar to that software development lifecycle that I showed at the start, basically, where everything was really split up and siloed. Super, super time consuming, and every single step of it is done by humans, basically. Agile working was then introduced, and DevOps is basically an evolution of Agile. It's not a replacement for it in any means, it's an evolution of it. And it's a lot more of a cross-functional process, essentially. So One thing that's quite interesting is I think most people refer to continuous integration and continuous integration pipelines as part of something that has been introduced with DevOps, but it's actually part of the Agile methodology and Agile manifesto, I think they called it at the time. So yeah, a bit of an interesting one there. The person that coined the DevOps name and I guess thing that we talk about today was a guy called Patrick Dubois. I think I'm pronouncing it rightly. And he actually coined it after working on some huge government projects. He basically was working on these projects and realized how slow moving they were, how siloed they were. And the term was inspired by Flickr, who were essentially making like 10 or more deployments a day, I think. And they did that by combining their development team and their operations team, which is where that term DevOps comes from, basically. A little bit later down the line, other big enterprise companies like the likes of Lego, Nordstrom and Target, as you can see, followed suit. And then, as we know now, it's pretty much widely adopted in the majority of tech companies to some extent. Yeah. Pretty wild fact at the bottom there too, that Amazon engineers are now deploying once every 11.7 seconds, which is pretty wild to think about that entire process that I spoke about before is kind of happening within 11.7 seconds through all of that automation, which is pretty interesting.
And I think a big thing within DevOps and the deployments is that a lot of time you won't even know it's happening. So we deploy a lot of hackajob, and the real intention there is that customers aren't even aware that what's going on. They see new great features, but it's happening in the background to the extent that it's not affecting their experience. So if you're deploying and your users are noticing, a lot of the time it's not a good thing. So that's an important part of DevOps as well.
Yeah, I guess if the users are noticing, then something's going wrong within that DevOps.
Exactly that. Yeah, exactly. They're noticing bugs, and the whole point of continuous integration is that testing is happening as you went along. So you shouldn't be seeing bugs.
Yeah, totally. Cool. The benefits of DevOps, there's loads of different benefits of DevOps, as you can kind of see from that diagram. But a few key ones to think about and talk about, I think. First of all, rapid delivery. So as we can see from Amazon updating their product and their application once every 11.7 seconds, that would not be possible without DevOps and the ability to automate those processes. If it had to be passed from team to team to team, it just would not be doable. So yeah, it shows you how much quicker you can deploy your code when your processes are automated with DevOps. The speed side of things, similarly to that rapid delivery, faster time to market. It's easier to release products quickly and get them into the hands of the customers because you can get through the processes a lot quicker. On the reliability side of things, so there's a much more kind of lower failure rate of your releases because of the automation that's put into the processes to continuously test the code, as was just talking about. Most of the time, people don't even know that it's happening because the processes integrated are that reliable. Users don't even know that the software is being updated, and that shows the kind of reliability essentially. And then finally, just scale, I guess. You can manage a lot more complex systems with a lot lower risk because you're continuously testing it. You're continuously monitoring your code once it goes out there and it does get deployed, making sure that anything that maybe has gone wrong would be retracted, meaning there's a much lower chance for human error essentially, and that everything is kind of being checked along the way.
And I think the two things I'd add on top of that is that I had a conversation with a CTO at one of the major telco businesses probably about 2 years ago, and we were chatting about deployments and what changes it's made. And one of the things he raised was one of their rivals at one point was deploying at 2x rate that they were, and what they were seeing was, as a customer, the customers were getting less features coming through, and that meant that they weren't as competitively advantageous as their rivals. So over time they moved and they brought in more DevOps teams to focus around that, and that returned the ROI, which is the faster ROI at the end. You've got to think about it that if a feature is sat needing to be deployed for 3 or 4 weeks, that's a feature they're not getting any ROI from. So the quicker that they can get a feature out there and into the public domain, the quicker that they'll see ROI from it, and that's one of the important factors of DevOps.
Yeah, definitely. I feel like, as with all companies, it's about getting it as quickly as possible as into people's hands, right? And if another company's doing it better and getting a feature into a customer's phone or an application or something that's working a lot better, then they're obviously going to move on to that one. So it shows how it is into all processes.
100%. It's often not the best one in the market. It's the one that's first to market. So Netflix is great. Like, don't get me wrong, I love Netflix, but I think Netflix is always the one I think about because it's the one that I used first. Amazon and Disney Plus are good services, but I've been using Netflix and it's been my go-to for 5-6 years, if not more now. So that's always the service that I go to, and that's the one that I probably would never turn off because it's the one I'm most used to. But if I actually look at the functionality, I actually think Disney Plus it's got the best functionality on it. So yeah, I think that's just a consumer fault.
Yeah, that's interesting. It's always the first one you remember, right?
Exactly.
First brand in your brain, and the first one you start paying for, and then it's all the additional payments.
100%.
Okay, cool. So DevOps maturity. So as I mentioned a few times now, DevOps is an ongoing process. It never ends. It's not something that can just be completed and you move on from it and say, yep, I've done DevOps, guys. That's it. I've completed it. So as you can see, kind of starting with the waterfall methodology, you would then move into continuous integration. So that's basically saying when a dev writes a new piece of code, it automatically gets integrated into the wider code base via automation and via an automated process, rather than that manually having to happen, essentially. After that, you would then move on to continuous delivery once that code has kind of been integrated into that wider code base, and that piece of code would then be tested via a list of automated tests, basically. So you're automating adding the code into the code base. You're then automating the tests to make sure there's no bugs that's going to break the system. Then finally onto your continuous deployment. So this is the bit that's a little bit more risky and sometimes still done by humans, I believe, in some companies, because this is where the kind of, if the code has gone into the code base, it's passed the test, it will then go live straight away and kind of affect the application, essentially. If something does go wrong at that point, then obviously it could crash an application, which normally people want to avoid. But to achieve a full end-to-end DevOps process, then the deployment would also be automated, essentially, and that's how it would work. So DevOps Nirvana, this is basically the ideal or idyllic DevOps process, I believe, and what we'd be looking for to kind of tick all the boxes throughout a software development lifecycle and integrating DevOps into all of it. So first of all, you start, as you can see, with the developer committing new code to source version control. So that's basically committing code to the main code base, essentially using something like GitHub, for example. The next step is the continuous integration. So it notices there's been a new commit and builds the software. You then run into the automated testing. So once the software is built, there'll then be a series of automated tests, which will run in an isolated container away from the main code base. So that's kind of the containerization side of things that we talk about. Away from the main code base to execute those tests and make sure there's no bugs, basically using testing tools like the likes of Selenium and those kind of things that we might have heard about. If it passes those tests, the orchestration software will then start to deploy it to cloud services like the likes of AWS, GCP, Azure, those cloud servers that we've heard of before, and it will start then being visible to your end users. Your monitoring tools will then make sure that nothing bad's happened. So nothing's crashed, nothing's failed, even though it's gone through all those tests and everything along those lines, and everything's working as we would hope, and we don't need to pull anything back on any releases, essentially. Then finally, the CI server will send a little message to your dev team to just say, congrats, it's live, it's all been automated. You're basically a DevOps pro. And yeah, this shows kind of basically DevOps is integrated in all of these parts and it's automated without a human having to do any of this other than writing that piece of code. So yeah.
I think the final thing I would add on top of that is when you look at Nirvana, the reality is that nothing's perfect. So DevOps engineers, more than any other engineers, still work in a similar system to how like a sysadmin works or a systems engineer works, where they're likely to have on-call. I'm sure that a lot of you out there have that within your organizations because they are in charge of deploying this software. So while there are monitoring tools to analyze the behaviors, the reality is that at times something is going to get through the net. So it's not surprising for a lot of organizations if they have an on-call system. And if they don't have an on-call system in their DevOps team, it probably sits with another team. So it's only really organizations that have systems engineers or sysadmins that have completely moved away from on-call schedules. Cool. So that kind of moves us on to onto my section. So backgrounds of DevOps engineers. There's typically two backgrounds that a DevOps engineer might come from. So it might be software engineers, and I'm teaching suck eggs a little bit here, but bear with me. So software engineers, they're obviously responsible for new development of code. They've got a strong understanding of programming languages, and as you get into different areas of DevOps, you move to a point where you want DevOps engineers to not just be able to script in a language, but to be able to completely code in a language. Oftentimes there'll be experience with cloud technologies, at least in a modern software engineer, which means that that's an easy transition over time. So typically two types of areas of DevOps engineers. So there's the programming cloud side, and then there's the more infrastructure side, which moves into the sysadmin stuff. So sysadmins are responsible for management and upkeep of infrastructure, responsible for scheduling deployment releases, and then they're proficient in tools such as Perl, Bash for scripting. So it's the combination of those two disciplines that move into more of a DevOps functionality. So these are a couple of different types of DevOps engineers. With a couple of these, I've put the unicorn on the left-hand side because they are unicorns. So you've got the DevOps engineers that are typically a combination of the two. You've got site reliability engineers, and as I said at the start of this, the words give you a bit of an indication of what these people are focusing on. So site reliability engineers are usually strong in coding, and their main focus is to make sure that the site is reliable or the application is reliable and nothing is going wrong. So they need to be strong coders, because oftentimes they'll be the first in line to go fix something if something goes wrong. So in the same vein that you've got stuff like SDET, so software developers in test, a site reliability engineer needs to be strong on that side. You've then got DevSecOps, and this is becoming more common over time, but it's still what I probably would call a unicorn role, or a purple squirrel, people might refer to them as well, where there's not many of them out in the market. So if you're looking for a DevSecOps engineer, you might also look at someone from a security background, but oftentimes they won't have the experience in either the cloud or in infrastructure. So it usually means you need to upskill someone. So you're usually looking for a combination of maybe two of those three disciplines and then upskilling in that final one. So a lot of the DevSecOps engineers that we help clients with will come more from a DevOps background. So they have that sysadmin and software engineer, and then they're learning the security. You then get cloud engineers that are focusing primarily on the cloud. So AWS, Azure, GCP experts. You then get Linux and Windows engineers that will be really strong in the operating systems and the infrastructure side, and then the sysadmins, which we kind of touched on at the start. So key concepts. So an important one, especially with those cloud engineers, is cloud platforms. So a cloud platform basically refers to the operating system and hardware of a server in an internet-based data center. So when we were talking yesterday, for anyone that was part of that, about cloud and how it sounds like it's up in the sky, but the reality is it's a data center just somewhere else in the world. That's what we're talking about from a cloud platform perspective. Infrastructure as code, so it's exactly what it says on the tin. So it's the process of managing and provisioning computer data centers through machine readable definition files rather than physical hardware configuration or interactive configuration tools. So it's essentially using code to run infrastructures off-site, so within a data center. So it might be, I don't know, a data center in Arizona, and what you're doing is you're using code to run that infrastructure in the background. So running VMware or running virtualization tools or any kind of OS. And then you've got configuration management, which is the process of maintaining systems such as computer hardware and software in a desired state. So what it is in that side is it's looking at running configuration across not just one computer, because in the past, what you would do is you configure each computer and each server and each database on its own in isolation. So you'd have one person that focused on setting up your systems, and then the engineer would go in and do the coding. The reality is now, as we move more to a remote world, and DevOps is a huge part of why we've been able to work remotely, as we move towards more of a remote world, someone's code will be held elsewhere. So it might be held in the server, some of it in, I don't know, Shanghai, some of it in Chicago. So using configuration management tools means that you can hold the code in different places and then you can bring it together as one. So the importance of that means that you can have teams working in many different regions and many different locations at the same time or at different times, and they're still able to work from the same code base. You then get CICD, and Sophie has touched on this already, but basically it's the method of frequently delivering apps to customers by introducing automation at stages of the app development. So what it essentially allows you to do, as Sophie said, is to get through everything in an automated fashion. So the Nirvana is that a human doesn't need to really interact at any point. So once the code is in the containers, which we'll touch on in a minute, everything from the integration to the delivery to monitoring afterwards is handled by computers. So the best way that I always think, and we'll say this about data scientists when we get onto that tomorrow as well, a good DevOps engineer is essentially putting their friends and their colleagues out of a job. That's the whole point of what these guys are doing. The more they can automate the tools, the less humans you need, and the more a company can return ROI. And that will mean that over time, these people will need to move into new roles where we've not automated it yet. But that's the whole point of what a software engineer does. They are creating applications to put humans out of a job. And it's been the same since Henry Ford. So it's not a new concept. Containerization, which we'll touch on in a second, so I won't spend too much time on it, but it's basically virtualization, and it's putting the code into container isolated from the rest of the application to ensure that if there is a bug in the code, it doesn't take down the whole application. So it puts it into container, and you can look at all the code, you can play around with it, you can see how it's going to interact with your application by putting some of the application in the container with it, and then you can see if there's going to be a problem along the way. And then finally, pipeline orchestration is basically means you are putting the jobs into an order, which will then play out to get to the end goal of what you're trying to achieve. Cloud computing, obviously touched on already, but I think that when we're talking about cloud computing, there's pluses and minuses to it. The example I gave yesterday about one of the main benefits is that if you have stuff on premise, it means that it's not very cost effective, because you are having to use that same server power throughout your time with the application. Whereas the reality is that what you really want in it probably is, if you are a company that are running software like hackajob, most of our traffic will be between the hours of 9 a.m. and 5 p.m. because that's when people will be using our software to look for great engineers. So really, during that time, we want the servers to be red hot and scaling up. And then over time, when we get to 9-10 o'clock, there's not many recruiters going out there looking for engineers because they're at home with their family. They might be in bed by that point. That's usually when I'm in bed. We want it to scale back down. So the scalability isn't there if you don't have cloud computing. But as I said yesterday, most companies will have their data both on site or on premise, they call it, or in the cloud. And the advantages to that is that if the data center goes down in Arizona, let's say, all your data is still accessible because it's sat on site. But usually you'll keep the important GDPR compliant data within a data center that you run, and then you'll keep the stuff that maybe isn't as important or as legally taxing in another area. So there's a couple of different service models. There's infrastructure as a service. So this is basically the infrastructure that is provided in a cloud functionality, and it provides infrastructure, servers, storage, network resources, basically like a virtual data center. And there's a couple of examples in there. I won't bother going through all the examples, but there's some on there. There's then platform as a service, which is basically a third-party provider which delivers hardware and software solutions, and it's all done over the internet. and then there's SaaS. Best example is always hackajob, but what essentially is a software license where you are basically paying for what you use. So you aren't paying for you can kind of scale it up and scale it down as the day goes on, and you're only paying for what you use during that. So you're not paying a license for unlimited access, but because of the fact that it's software at your service, so it's what you need, it likely means it's a lot more cost effective than using a solution which is always on. I'm sure this isn't teaching anyone too much here, but these are the three big providers. AWS owns the majority of the market. I'll touch on in other markets in a second, but in the US, AWS is very much the biggest provider. It then goes Azure and then GCP. I believe, although I haven't looked at the numbers, probably in 2 or 3 months, but I believe that AWS owns about 55% of the market in the US. Azure's got 20 odd percent, and then Google was catching up quite quickly, but it still was under 10% in the US. I think over time you'll see that catch up quite quickly. It's the fastest growing of the free ones, but it's the third in there right now. If you look over to Asia, actually Alibaba is the biggest provider of cloud computing or cloud infrastructure. So it's interesting that in the US and in Europe, these are the free ones, but as you go across the different regions, it becomes other ones. So you'll probably notice that depending on how big your organization is, that maybe you have a cloud provider in one location that is, let's say, Azure, and then in another location use GCP. I won't spend too much time on this, but I think the one that I haven't really touched on too much is the security. So it can be argued that having it on premise or having it in the cloud is more security effective or less security effective. So the advantages of having it on premise from a security perspective is that someone needs to break into your servers in order to do it. The problem with it being on the cloud is this is data that is held by an organization that really you are putting your trust in that nothing's going to happen. There's a really good example, which is PlayStation. And there was someone that broke into the PlayStation servers, and they took down PlayStation Network for about 3 or 4 days and held PlayStation ransom. And all that stuff at that point was held on the cloud. So there's definitely advantages from a security perspective about having it on. There's also the problem that you are putting your security in someone else's hands. This kind of touches on a lot of what Sophie was talking about earlier, but I've just put a couple of examples on here of continuous deployment, etc. tools. I would say that the ones you typically will see from continuous deployment is Jira and Confluence, both tools that we use at hackajob. From a continuous deployment, generally, I would say that nowadays, if you look at a modern stack, it would be Ansible, or SaltStack probably. Puppet and Chef tend to be more older tools, but it depends on how big your organization is and how much things are moving across. From a continuous monitoring perspective, Splunk is the big one. I know quite a few people at Splunk, so big shout out to Splunk. Continuous integration, Jenkins and Bamboo are the main two. And then from a testing perspective, I would say it depends on the tool you're using or the back-end language you're using or front-end language you're using. I would say Selenium goes across most of them quite well. But if you're a Java house or a C# house, you might be using NUnit or JUnit. So from an insights perspective, DevOps, because of the nature of it being a cloud solution or a cloud way of working, we see that the staff follow this kind of lead, and they tend to be based more sporadically across locations. So 9.7% of the talent is based in San Francisco, 7.4% of the talent is based out in New York, 7.4% of the talent is based in DC. So this is the only one where, when we were looking at the recruitment insights through hackajob, actually it's as prevalent in New York as it is DC. 7.3% were based out of Dallas, and then 4.1% in Chicago. Locations with good supply compared to roles. So people have probably heard this a few times now, but essentially what I'm talking about here is I'm talking about not that these are the areas with the most supply, but these are locations where there aren't as many roles in comparison to the percentage of engineers that these locations hold. So Washington, DC, Boston, and Seattle, the big three on that side. Washington and DC tend to be quite expensive places to hire out of. Boston is too, but it's relatively cheap in comparison. We're seeing quite a few clients move towards Boston and into Rhode Island. So I think that over time you might see that change. But I would say that these are three good locations to find people at the moment. Actively hiring, as I said yesterday, I think that the reality is that if Google and Apple were hiring at the same kind of rates as they usually do, you would see them on here. But right now, Capital One are on most of the slides that we're pulling because they are hiring so prevalent in the moment. But it's interesting that you're seeing Accenture and PwC and Deloitte on there too. DevOps and cloud tends to be quite a consultancy-based area, because again, you are spinning stuff up and spinning stuff down. So depending on the projects you're working on, you might pull in Accenture, PwC, Deloitte, those kind of consultancies. So when we're working with a lot of consultancies, they have big DevOps teams. So might be an area from that side. And then at the market, so 74,000 DevOps engineers in the US. And what we're looking at here is purely DevOps or site reliability people. 25,600 vacancies. And then there's 2,100 active engineers. So these are engineers that have said, I'm actively looking for a job. And that means that there's 12.1 jobs for every engineer. So it's a very, very competitive market. I've seen there's a couple of questions already in the Q&A. So let's get on to those ones.
Well, tough odds.
You want, sorry?
12 to 1 is a tough odds.
It's very, very hard to hire good at DevOps engineers. And that's why I think that I think if you look at the spread of the market, it tends to be a not very diverse marketplace. So when you look at site reliability, if you look at sysadmin, it tended to be an infrastructure, it tended to be a very male dominated marketplace. So when you look at the diversity in that marketplace, is really, really hard. There's one of the major software players that most people will be aware of. We had a conversation with them probably 2 years ago, and they were saying, how do we hire female DevOps engineers? And they gave us the list of the things they were looking for. They gave us the salary they're looking for. And we said, right, okay, this is your marketplace. There are 32 engineers out there that are within what you're looking for. And it's because, well, and what we said to them was, if you are looking for that finished article, they're really, really hard to find. So what you want to do is you want to open up your requirements a little bit. So what they ended up doing was they hired software engineers that had an appreciation for cloud. Just that we said to them, look, if you're looking for female DevOps engineers, there's not many of them out there with exactly what you're looking for. So if you change your requirement for this, it might take them 3 months to get upskilled, but the reality is that you will get them upskilled and they'll be appreciative of everything you've done.
If you can find a new engineer, like you can teach them, people can be adaptable and stuff like that, provided someone's got a passion and they're willing to learn. These are the most important things. Yeah,
exactly. Cool. So from a question, wow, we've got 5 in there already. So I've been asked to source candidates with Agile and DevOps and experience. So DevOps works with Agile sprint-based environments as well. Yes, it's essentially an evolution of Agile methodologies. It can work with a waterfall methodology. Don't know where you work, so I'm not sure if you work with Agile or waterfall, but yes, you absolutely can find candidates with Agile. It tends to be pretty normal now. Most organizations will work in an Agile sprint type environment, so yeah, you shouldn't have too much of a problem on that side. Work in would DevOps work in extreme programming methodology? Could you just clarify? Apologies. Could you just put in the chat exactly what you mean, or exactly what you're looking for from that side? Because it depends on that. There's a little bit more, like extreme programming methodologies is quite wide. So yeah, if you could send that across, that'd be good. What is DevFinOps? DevFinOps is an interesting one. I only came across it probably 5 or 6 months ago. So what DevFinOps is essentially someone that isn't fully on the tools anymore, let's say. They are focusing on looking at your spend within DevOps. So they're looking at the tools that you're using, and they're looking at whether you can spend more efficiently. So they might look at, I don't know, are you scaling up or scaling down your service at a quick enough rate? Would you be better off using AWS rather than Azure, the advantages, etc.? So the reason that you would still have a technical person doing that is they understand this stuff. So it's someone that has an interest in finance, let's say, but also is proficient with the tool because they understand exactly what everything is doing. It's a really, really new age one. The only time I've seen it is through consultancy. So I don't know if you work at a consultancy, but I've not really seen it in software houses. I think we've answered this one, but what is the most popular cloud provider? Depends on the region, but mainly it's AWS. Is the main one that we're seeing right now. GCP is catching up. One of the things that I've seen GCP do in the market in the last year or so is they've got a big push when it comes to offering their clients access to all of their learning tools and learning material. So that's had a big push on that side. So it essentially means that you walk through the door and you've got $20,000 worth of content that you can walk in and utilize. So it's a really good L&D opportunity. So they've been using that really well. One of the telco brands we work with here at hackajob, that's a big selling point on their side because GCP will be having a big push in the next few years. What is the difference between a site reliability engineer and a test engineer? Sophie, I've gone through quite a lot of them at the moment. Do you want me to take this?
Yeah, you go for it.
Yeah, cool. Yeah. So a site reliability engineer will be focusing on looking at the systems and how would I best describe that? It's a really interesting question. So they would be looking at the systems and whether the automation is working rather than whether the software is working. So they aren't focused, DevOps engineer isn't focusing on whether the code works, or a site reliability engineer isn't focusing on whether the code works. They're looking at whether the code goes through the systems okay. The test engineer will be focusing on developing testing frameworks and testing methodologies to see if it goes through. So a site reliability, in some ways, they'll look over what a software engineer is doing, what a test engineer is doing, and then focusing on whether it automates well. Whereas the software engineer is focusing on the actual code, and then a test engineer is working on whether that code works, if that makes sense. We will go through this in a lot more detail on Monday session. But they are different roles. But as we've said in most of the sessions this week, over time, we're seeing that teams are less siloed. So a site reliability engineer nowadays will probably do more stuff that is focused around testing. A software engineer will probably focus more around testing now. And in testing engineering, you've got something called software developers and test that are essentially testers that are skilled enough in coding to be able to go in and fix any like small bugs that they're seeing. So we're seeing a merging of a lot of different roles, but hopefully that explains it. If not, like I've said on most of the sessions this week, reach out to me on LinkedIn. I'm more than happy to jump on a call to answer your specific question. Hopefully that did though. How many times a day should we expect to deploy? Depends on the size of the organization you're working within. Not many organizations are going to be deploying at the same rate as Amazon. Generally, for an enterprise organization, you're probably looking at somewhere between 30 to 40 deploys a day. But oftentimes it will depend on whether you are a B2B company or a B2C company. B2B companies tend to deploy at a slower rate than B2C because a lot of deploys from a B2C side will be stuff that's going through like a website. So they'll be deploying fixes to stuff they're seeing maybe in their baskets or stuff like that. Why would we expect increase or decrease in server usage? So as I touched on earlier, it depends on the hot times of the day, let's say. So let's say you're Amazon, you would expect that you're touching on load balancers from yesterday. You'd expect that your load balancing is being put under more pressure, let's say between the hours of 7 and 10 o'clock when people are at home looking at purchasing stuff online. And then you'd expect between the hours of 2 a.m. and to maybe 6 a.m., there's less going on. So there's a lot of tools out there, and I won't play favorites here, that what they essentially are doing is looking at how are you using your servers and how are you using your cloud at the moment, and they will basically charge you on spinning it up and spinning it down. What are the advantages of having a separate DevOps team? So DevOps engineers, in the same vein that there's test engineers or software engineers, they are experts in their own marketplace. So the advantages to it are essentially that that they understand cloud more than someone else, so they understand virtualization tools more than someone else. So it's essentially having an expert in that marketplace. There is obviously people within the team that probably understand it, but they won't understand it to the same level as as what a DevOps person would. So think about in the vein from a recruitment perspective of, you probably in your team have generalists that are focusing on all areas of the business, and you've probably got people that are tech experts, and you've probably got people that maybe are commercial and sales experts. Yes, you could put your generalist recruiter on all of the different markets, but the reality is they don't understand it in the same vein as maybe your tech recruiter or your commercial recruiter does. So you might pull your software engineers to help on some of the DevOps stuff, but you probably don't have them working on everything at the moment. Typical backgrounds, kind of touched on this as well during, I think, slide 3 or 4, but you typically will see someone either come from a software engineer background, so focusing on core coding, or you'll find someone come from an infrastructure side. One of the things that I think is very interesting is, and I don't know how much this is changing within education now, but if you look at most computer science degrees at college, you don't tend to learn a lot of the elements that are DevOps focused. Generally, someone will come through as a software engineer, and if they typically have come through the sysadmin route, they would have done that through joining the organization, maybe in a first line support, then a second line support, moving up through the ranks into a DevOps role. So depends on the route you go for which route you'll go through. But I think that over time we'll see more cloud focused elements within computer science modules and majors. So I think that will change over time, but generally it's from infrastructure or software engineer. There aren't many routes where you'll go straight into DevOps. We struggle to find diverse talent in our cloud team. What advice would you give? So my advice on that side would probably be to look at what are you looking for exactly, and is there an element where you can make a change to your requirements. So I don't know, if you're looking for someone that knows Terraform, Python and AWS, could you make a change within that requirement? So maybe you're looking for someone that is a software engineer, so knows AWS, has maybe an appreciation for Terraform and infrastructure as code, and knows Python. So they know probably 70% of what they need to know, but they're not the whole way along. So I think that maybe open up your requirement a little bit more so that you can find more talent out there. There's a lot of candidates that want to move into DevOps, but maybe haven't had the opportunity. And I think the more you can bring in someone that isn't 100% the finished article, both they will appreciate you more as an organization because you have taught them something. And also, as I said on a couple of the different sessions this week, if you bring in someone that knows everything, they'll get bored very, very quickly and they'll leave your organization. So it's always good to bring in someone that doesn't know everything. Our company wants us to hire DevOps engineers who can also code. How common is that skill mix? So I would say it's fairly common. What I would preface with that though is that these tend to be the much more expensive DevOps and cloud engineers. So if you look at someone that comes through the infrastructure route and maybe knows Perl, Bash, and those kind of scripting tools, they might cost you 70% of what an engineer would cost you if they knew all the tools that I spoke about with Terraform, Ansible, and Python. So I think it depends on your budget. There's a lot of candidates out there, but as with everything, they usually get snapped up by those tier 1 type companies. So if you're looking for someone that knows everything, be prepared to pay big bucks for them. I would also say it depends on where you're located, which feel free to put that in the chat. But in places like a New York or a San Francisco or a Seattle or a Dallas or an Austin, where there are lots and lots of companies, you'll probably find lots more candidates out there. So I'd say that if you want someone that is a strong coder and stuff like that, maybe you should look at remote, because it will offer you a lot more opportunities. Any specific websites, forums, groups we can search for DevOps candidates in the US other than well-known job boards? I'm going to say hackajob.
I was waiting for that.
Yeah, I was going to say I have to pitch us. Hackajob is a really good place to find DevOps engineers, SREs, etc., etc. But I would say when you're looking at how to find candidates, it's always good to get deep into that marketplace. So probably avoid going on to the traditional methods. So I don't know, places like Monster, places like LinkedIn. Like LinkedIn's a good tool, but the reality is that a lot of these engineers don't live on these websites or these social media tools. They live more in stuff like GitHub, Bitbucket, Stack Overflow. Go to meetups. I would say going to meetups is probably the best thing you can do in this marketplace. The more you can talk to candidates on their level, the better. But don't try to go over the top. I think that one of the things I learned very quickly when I moved into tech recruitment is don't pitch yourself as knowing everything, and pitch yourself as being a DevOps expert. Go out there and speak to people and learn the market and build your own network. And that will come. Hopefully that helps.
Sorry, on the GitHub side of things. I found personally candidates absolutely love it when you reach out to them on GitHub, when you've kind of said, like, I've seen your work, I've seen the tools you're using. It shows that you're on it. It shows that you kind of know what you're looking for, and they really, really appreciate that, I think. So I think that's always quite a nice way to approach people with that kind of skill. Sorry, it was just one thing to add.
No, I love that. Vijay said that we're a remote first company. Amazing. That's going to help you to no end. I think the US market is really, really interesting one, because people working across time zones. And because people working across time zones, it means that oftentimes, because of what I touched on earlier, where you might have people that are working on after hours or working on through the night, it probably means that you need to be more aware of time zones. But I would say that if you can hire across different time zones and remotely, that's going to do you all kinds of favors. The last question, I have a client looking for a chaos engineer for my first time sourcing for this type of role. I'm going to be totally honest. Can you reach out to me on LinkedIn or an email? I've never heard of the term chaos engineer. So it does sound like the kind of thing that a DevOps engineer does and kind of deals with, but I've not heard of the term chaos engineer. So either I've missed something in the marketplace, which is likely, or they are using a synonym and using a different title for it. So please do reach out to me on darren@hackajob.co or on LinkedIn. Give them a bit of an idea about what they're looking at from a skill set perspective, or chuck in the chat now. And then I can give you a bit of an idea about whether these are typically going to come from a DevOps team or what kind of team they're going to come from. I think it sounds more like a SRE type background, but I need to know the skill set.
A name for something. The tech industry absolutely love doing that.
Exactly. coding ninjas. Everyone likes a coding ninja. So cool. Any other questions? I think we've also answered is DevOps a part of Agile?
Yeah, I think so.
Yeah, so that probably would fall under the site reliability element of it. So yeah, you're probably looking at someone that understands coding at a pretty decent level. So it's probably more an SRE you're looking for than a typical DevOps engineer. They're all synonyms, to be honest, as I kind of touched on in slide one. So let me go back to it. So when I was on this slide, the reality is, as I kind of touched on, you can't focus too much on the titles that someone has, but they're probably looking at somewhere between that site reliability engineer or DevSecOps engineer, is the type of background you're looking for on that side. Thank you very much, Sam, for chucking that in as well.
We've learned something as well today.
I was gonna say, I love that. Cool. We'll give it another minute or so. We've actually got to 55 now, so.
The waiting game.
Yeah, that's right. We'll give it one more minute. While we're waiting for stuff to come in, a lot of the questions I always get after these sessions are, where can I find this content? Please do reach out to me on LinkedIn or on my email that I gave, just for clarity, darren@hackajob.co. Anyone that wants to connect me on LinkedIn, please do. Quite a few people connected with me last night. I think I walked into about 30 people connected with me, which I love. So reach out to me if you've got any other questions that maybe you're not comfortable chucking into the chat or on Q&A, send them to me. I'll be online for the next couple of hours, or tomorrow I can answer questions. Give it one more minute.
Yeah,
Sophie, is there anything you want to add before we jump off?
Just likewise, really. Yeah, if anyone has any questions about anything that I covered or wants to reach out, please feel free to connect with me on LinkedIn. I'm more than happy to kind of get back to anybody and also chat to anyone a little bit more about tech or DevOps or anything else tech related. Always interesting to start a conversation.
Awesome. I'm seeing the numbers dwindle while we chat through this. So what I'm gonna, and I'm also seeing people connect with me because I've seen LinkedIn suddenly pop up on my phone. So thank you so much for everyone that attended. Thank you very much for the lovely Sophie for joining us today. Tomorrow's session will end the week on data. So we'll take you through data engineering, data science, data analysis, and a bit of AI. My favorite subject, if I'm honest. So please do come and join. But have a great rest of the day, and see you all soon.
See you later, everyone.